One of my areas that I was in charge of when I worked for the Ohio Division of Wildlife was really looking at project design and things like that, not only what we did, but also what universities came to us like that. So sample design is really important to me. But most of what I'm going to try to talk about here today isn't so much the sample design, but a standardized protocol. Protocol that then is usable in multiple sample designs. We have multiple questions. But one of the real problems we have is everybody's doing their things differently, and you can't compare. It's apples and oranges, and then you have a federal agency that has to make decisions. Is it a good place or a bad place? Or is this place better or that place better for wind turbine, something like that? And they can't compare anything. And we've been working for several years really trying to get a more of a regional approach. And so what I'm going to kind of go over is kind of going to meander a little bit, but getting at the importance of having a protocol that is usable in multiple sample designs. Because you're going to have certain questions here in Wisconsin. Ohio may have different ones, but we all have a Great Lakes question. And we want our data to be able to go to a Great Lakes project. There's a lot of site attributes to stop over. This came out of a Western Basin of Lake Erie working group, Nature Conservancy, both Ohio and Michigan DNRs, Black Swan Bird Observatory, Ohio State University. We're all working together to come up with, okay, what do we think makes up a stopover habitat? We're looking at here not as the active migration area. We went through all bird groups, but what do they need when they're stopping over to refuel? From that you can come up with a GIS type mapping, and it's what we think. Doesn't necessarily mean it's what the birds think. And one of the real things that our biggest concern is what if we're wrong? How do we gather data to get this more of an informed decision making? The blue areas being, this is the Western Basin Lake Erie. This being the island, the Bass Island Archipelago going over to Point Pelee. This is coming around. This would be Toledo right in here. And then blue, basically, this is for the land birds. It was done for land birds, waterfowl, and shorebirds. All different groups had different maps, and we get able to interrelate them. So it had conservation, land management applications. But again, this is what we view as what's important for them. So really you want to have goals and objectives, and I think that's a lot of what you're working on here, is trying to develop what is our real goals for this region. But you need to focus the direction. Right now there's a lot of people doing stuff in the field, and we're not talking. I mean, some of the stuff hearing what's going on in the Northeast here, I've known a little bit about some of it. But we need to be talking more, because what goes on in the Northeast and what goes on the Great Lakes is the same resource, because the birds are all going north of us and going south of us, so we need to be talking more on that. And what I'm presenting here primarily has to do with land birds. We have a whole different thing going on for shorebirds, raptors, waterfowl, and the waterbird group. What I'm here is really dealing with a land bird protocol. And there's a lot of different objectives and a lot of different questions you have. A research project has 5 major parts. You have the question, you have the sample design, you have the data collection, you have analysis, and you have publication. 1 and 2, if they're not done well, it doesn't matter what you do after that. You've got to have a good defined question, and then you have to have a sample design that gets at that question. And that's really where most groups put their, it's fun going out and collecting data. Some of us like to analyze it. None of us do a really good job in publishing it. But the real time should have been put up in the first 2 parts. But you can come up with a lot of questions, species timing, okay, that's great for a local area. When are the birds coming through? You have a public out there that wants to know that. The more they're involved in understanding it, the more they're going to be there at the ballot when issues come up. But species timing today, species timing 20 years ago now have global climate change ramifications. So what seems like a very simple thing has long-term effects as well. Same way with bird condition. That has a lot to do with, are you doing a good job in managing your land? And then it goes back into land management agencies. Then you get into the methods analysis. You have this great idea, but then you have limitations, you have obstacles, and you got to stick with what is your primary needs. And everything you do has to be dialed in with those caveats that you can't control. And other ones you can and you need to. Funding is always there. If we had all the money that we needed, it wouldn't be too detect radar units in fish monitors in the Great Lakes. It would be about 52. We'd have it all scattered around, gathering data simultaneously across the landscape, so you don't have some of those, well, you can't compare two sites because they weren't done at the same time. It makes it very tough to do that. But funding is always going to be an issue, so we have to make wise use of what funding we do have. But probably more dangerous is some of the sample design assumption errors that were made, or used because you think it's the only option. Data misuse. There's a lot of that potentially going on, quite honestly, and you could say this is a advertisement, whatever, but there's a lot of it going on in the wind industry right now. They manipulate data to look like they want it to look. Data dredging, extremely dangerous. Because stuff was collected for 50 years, it doesn't mean it was collected right for your question. So you've got to be very careful going backwards without a way of tying it to the data. Exceeding sample design is done regularly. The design, it fits what you think is the result, but it may fit 50 different other reasons. How do you tease them out? Speculation. That's always gets you in trouble. And then biological significance. Don't lose contact of it. It doesn't have to be statistically significant to have biological significance. There is importance to the descriptive statistic, which is what did you see on the landscape. Don't ever underestimate that importance. Just a quick example of how maybe the wrong data is worse than no data. So you've got to consider that in your sample design. And this is using the Tennessee warbler, which at least at the latitude of Lake Erie is a rapid migrator. We seldom recapture these birds more than a day or two after original capture. This is spring migration. So they're moving through very fast. There's other species of black and white. Black-throated blues are very slow movement. Now that may change as they get closer to the breeding grounds. We don't know. This would be part of a more regional approach, using the same protocol across the board. How does these birds use these areas? What goes on at Lake Erie may be very different than Lake Superior with the exact same species. And so you have to be careful using information from another area. But recognize it's very slow, a very fast migrating bird. This banding station, this is real data. This isn't made up, this is real data. Worked off, operated on weekends. Over a 6-year period, just kind of, for simplicity, standardized the different weekends here. There's 4 weekends in May. This is the actual banding of new birds in each of those days over those 6 years. You can develop a nice graph and say, okay, when is this bird moving through here? Very clearly around the middle of May is the peak of the Tennessee warbler migration. So now you have a timing frame that can fit into, 20 years from now, as the timing of this species changes due to climate changes. A lot of different questions can use this data. Problem is, migration doesn't occur on weekends. It occurs daily. If your sample design does not take into effect daily operation, you can get a very bad idea. This is the actual data. The bimodal peak, this is the males, this is the females. Males are on the 5th of May, females about the 12th of May. Now remember, you just said the 15th is the peak of migration. Because it's the wrong sample design for the question you're raising. And here's what you would have come up with had you been doing, just using station from this periodically rather than a daily migration monitoring station. This is all part of what fitting into this protocol. This is a multi-tiered, multi-method protocol that has flexibility. It can use to be answered a lot of different questions, but at least everybody's on the same page of how they're gathering data. But there are a lot of things you can look at. Even though we have possibly the largest banding station in North America, when you look at birds per 100 net hours. In the spring, we're averaging between 120 and 140 birds per 100 net hours. Banding around 10,000 birds every spring in one site, and we have some multiple sites. You still can't answer questions for a bigger landscape. Is what's going on, what may be the core of migration, would we expect to see changes occur there? This is just a daily for 1 year, showing the wave theory that created some time ago, that these birds, neotropical migrants, are coming through in waves. A wave is a species assemblage that occurs roughly the same time every year, because day length is the driver of migration. And you can pick out these, and then these can be plotted over multiple years to see what's going on. We look at the new birds banded per net hour. This is standardizing for net effort over a 20-year period, and basically you see no change. Now again, is this because this is the core? Now if we went out to the edges of migration, would that where we'd expect to see the first change if we have a population change in it? But you can see that annually, there's a heck of a lot of variability, and it's pretty poor R-squared. But, you know, it looks like we've got roughly the same number of birds coming through as we had 20 years ago at the station, Western Basin Lake Erie. We can look at individual species. Now here's one of actually our most common bird that we band in the spring is the Magnolia. And it looks like there is a slight uptick in the regression line, but a lot of annual variation. And that slight uptick could be almost explained by, 20 years of experience out of banders. There's a lot of little things that could do that. And to me, this is based on it's a relatively stable species. But it's an important species. In Ohio, it's a species of concern because we do have a breeding population in a portion of Ohio. Not really probably the portion that we would sample in the Western Basin, but there are places this bird is of importance to. But this is an extremely common bird. Because of the large sample size, you can do a lot more with them and maybe use them as a surrogate for other species. And then you look at some of the species that are in trouble. Here's a bird that's a candidate species right now. Through breeding survey work, which there's some problems with it because are we covering the full breeding range of this species to really look at what's going on with the golden wing? But when you look at 20 years worth of banding data, we're showing the exact same trends that breeding data is showing. So now you have two methods saying the same thing. What exactly that those curves are, there's going to be some slop in it. Here's a bird that's definitely going down in numbers. So it just adds to what is known through breeding surveys that migration data is maybe showing the exact same trend, which is now we're getting into multiple populations of the bird. So there's a lot of things that can be looked at. Then you want to look at, especially if you're trying to develop something for this area, what is already available to you? And when you look at for the whole region, there's, as I said, multiple methodology. It has already been pointed out that each method has its strong points and its weak points. What you want to try to do, because really to really look at population, it's going to be a modeling exercise. Bringing these all together into a modeling exercise, taking the strengths and the weaknesses of each and trying to get a stronger thing than what any piece could be. And it's mind-boggling how models do that. As they say, all models are wrong, some are useful. But, working on some DNA work when we were working on our canned goose thing, we only had about a 70% chance of correctly identifying the race of each individual bird, but we had a 95% chance of correctly identifying the breakdown of the races in the harvest. And it just doesn't make sense. If your pieces are all down here, but you can come up here. But bringing these different medicines together makes your overall ending much stronger. Banding, counts, which is surveys, radar, and acoustics are four major methods that are available. They all have their pros, they all have their cons, they all have their costs as well. And then determine where do you have gaps, and what is available to you out there that you can tap into. Because needing to know what you already have helps you start designing what you need, where you can have to put your money down. Banding programs, many are local, some have more regional approach, but you have observatories, you have volunteers, and you have universities. It all already has the potential to come in to a program that was there, more a regional program. I did this actually for the meeting last year at Midwest Monitoring Network, trying to get an idea of what is really already out there available, banding one. Now, there's a lot of caveats in here. One, each one of these represent a station that, depending on the number here, whether they band roughly greater than 300, greater than 10,000 a year. Now, that's taking just a suite of species that were migratory in the Great Lakes region for the most part. Now, we get up to this area, some of these, they're breeding here as well. But it's taken out all the resident birds. It's supposed to be resident through the whole Region 3 area. So those have been removed. These stations are banding more birds, but they're species that we don't think as neotropical migrant type species, or definitely migrant throughout the region. And then, okay, where do we have holes? If Wisconsin's interested in putting together, a migration monitoring network here that fits into more of a regional scale as well as your own question, where do you need to start establishing some of this potential? And interesting that really some of the most important areas up along Lake Superior and along the Mississippi are areas there isn't much work being done for whatever reason. Unfortunately, we only have really 2 stations that are really of major importance in the Great Lakes region. And we need to be looking at really trying to get that to improve a little bit.